So I'm going to go through a quick example of each of the more force concept builders from the physics classroom, just to give you an idea of how to attack those. So the first task would be force and motion. Make sure you do log into where it says your account over here to do that. I think I did. And I think when you click on your account, the tasks are described to you already. So I don't think you have to go over here to concept builders. If you do that, make sure you're logged in. So these are all Newton's laws. First one is called force and motion, which is right here. If you complete the horizontal forces only part of this activity, you'll get 8 points. If you complete both horizontal and vertical motions, you can get up to 10 points. And that is in standard F1 forces 1. So I am logged in because my email is there. This one you do not need to do. So this one for 8 points, this one for 10 points. I'm going to go to an example one of those. So these are motion maps or dot maps. I think we've seen these before in physics classroom. We'll see them again in class with some labs we do. If you're unsure about how to do that, remember you can go to Help Me. That opens up a new window. You can think about this question, you can think about the situation. If you want to go to where they talk about the dot diagrams in particular, you could go to this part of the physics classroom tutorial, dot diagrams or ticker tape diagrams. And this will tell you a little bit about how to use those. There's a quick video there, I think from somewhere, but fast, slow. So it's like a drop of oil coming out of your car every second or so. So the further their dots are apart, that means the faster the object is going. So back to this one. This has a net force to the left, balance forces vertically. It says the length of the arrow represents the strength of force, which dot diagram represents a possible state of motion. Well, this could not be at rest because we have an unbalanced force. These two indicate constant speed, so that couldn't be an unbalanced force. The arrow here says it's moving to the right, but if it's moving to the right, it would not be going faster and faster with an unbalanced force to the left. This could be correct. Unbalanced force to the left, moving slower to the right. This could also be correct. Moving to the left, going faster and faster. Let's check that. Data away, baby. So I'm not going to go ahead and continue with this, but that's the example of how you would do things. So now I'm going to go back. The second concept builder I'm asking you to do is to match those free body diagrams. So that's this one. You want to complete the master level for 8 points, complete the wizard level for 10 points. You do not need to do both. So I'm going to go to the wizard level, take a crack at one of these. So the physical situation is described over here. The free body diagrams will appear here. You tap here until to view your choices. So we've got a skydiver with an unopened parachute. It's falling downward through the air at a constant speed. That means they're at terminal velocity. So the normal force would indicate they're on the ground. That would not be correct, so I'll tap that again. This air resistance looks reasonable, except it says they're going at constant speed, and therefore these are not the same length. This seems more correct. So the skydivers reach terminal velocity. I'm going to check that answer. And data away, baby. So once again, I'm not going to go through other ones here, but again, you want to read the situation fairly carefully. So for example, this is a rightward moving car skidding to a stop. So if it's moving to the right, you would want to think about the direction that friction would act. So now I'm going to go back. I'm going to show you how to do the third task, which is air resistance and skydiving. That's still under Newton's laws. With this particular one, you're going to want to complete both two of the three activities in here. I'm only going to show you how to do one of them. So with this, you do not need to do the velocity time. We'll do those a little bit later in the year. You do want to do the air resistance and you do want to do the vector diagrams. Each of these is worth 6 points. If you do them both, they're worth 10 points. Let's try this one. So consider the spherical objects traveling through the same region of air. Radius and speed values are stated. Well, hopefully it makes sense that you have an object that's a bigger radius. It's going to catch more air. It's moving faster. It's going to catch more air also. So these all have the same speed. So I'm going to say that being the greatest radius would have the greatest air resistance. This would be the middlest, and this would be the least. I'll check that answer. If I wasn't sure about that, again, I can go to the help me. And do things like that. But I think that's pretty good. Hopefully those help you out.